Alright guys, so we are doing Unit 8, Lesson 4, and today we're going to learn about a process called completing the square. And this is an important topic for the quadratic unit, so this is kind of a difficult one. Hopefully you'll be able to follow along. And basically what it's saying is it's easy to find the turning point of a parabola when it's written in a certain form, like this one right here. If we gave you the quadratic written in this form, it's much easier to find the vertex than if we gave it to you in a trinomial form. So we're going to learn how to turn our trinomials into this type of vertex form here, or shifted form. So to start off, just a little review. You guys should be able to look at this and tell us what the turning point is. So go ahead and do part A and see how you do. So hit pause, try part A. Alright, hopefully for this one you got something here. The turning point is 3, 2. Remember, in the parentheses is our shift left and right, and this is the opposite one. So since it's negative 3, that's going to shift it to the right 3. And then the one outside the parentheses is, according to positive 2, would shift it up 2, and this one's the same, this one's opposite. So hopefully something like that. Then determine the range by drawing a rough sketch. So could you draw a sketch of this and figure out the range? Remember, that's all your output values. So hit pause and do that now. Okay, how'd you do on part B? On this one here, it's a rough sketch, so you can use your shifts. You know you're going to the right 3 and up 2. And look, there's a positive coefficient in front of the x, so therefore we know it's a happy parabola. Yay! It's pretty happy and kind of silly, but that's okay. And therefore, you know, this is the minimum y value here, and then it's going to go on to infinity up there. So that's what we could write here or here. Either one is fine. So hopefully that's going all right for you. The question then is, how can we take a quadratic in this form, standard form, and put it into shifted form, something like this up here? This is known as completing the square. And again, this is a little more complicated, but once you understand it, hopefully you'll get it well. And will also help you factor and solve quadratics. So let's go ahead and do a little review. You guys should know this. And if you can take the shortcut, go ahead and do that. But you guys should be able to express the following to equivalent trinomials. So go ahead and just do all 3 of these. And if you know the shortcut, go for it. So give that a try now. All right, how did you do with these? Let's see how well you remember this. So this one here, there you go. Remember, x to the 5th squared is x plus 5, x plus 5. I would skip this step for sure. Some of you guys might need this step, which is fine, but typically I could go from here to here, because you know you're adding the last terms and then multiplying the last terms to get your trinomial. So with that, let's see how you did on this one. You should have got x squared minus 2x plus 1, and C was x squared plus 8x plus 16. All right, just a little review. And these right here are going to help us what we're doing, so we'll refer back to them. All right, so each of the following trinomials is a perfect square. Write it in factored form. So now we want you to factor these. And as you can see here, this and this are perfect squares, perfect square, perfect square. So you should be able to factor these into the product of 2 binomials. So go ahead and do that now, please. So hit pause and factor. Okay, so before I show the answer, basically it's the opposite of these that we just did when you multiply these trinomials. You can see that that was a perfect square, that one is 2, and basically the square root of 25 is 5, so 5 times 5 was the 25, and 5 plus 5 is the 10. So when you see a trinomial, and this term is a perfect square, you could pretty much write it up here. Same thing here, the square root of 1 is 1 times 1, but to get negative 2, I'd do negative 1 times negative 1, and same thing here. So hopefully you saw that pattern and were able to factor these. Now, this is something you need to get down. You might not have seen this right away, but what it's saying is to get to this middle, these terms here, is if you take the b term and divide it by 2, and then square it, it will always get you the c term. And again, why is that happening? Let's look back at one of these. So remember, this term is added to itself. So 2 of these terms make up the b term. And then when you multiply these 2 terms, you get this one here. So if you were given just this, if you divide this by 2, that would be 5. And if you square it, that would get to 25. And that works every time with these. So if I divide this by 2, I would get -1, and I square -1, I get that term there. And again, look at the last one here. So if we divide this by 2, we'd get 4, and 4 squared is 16. Because remember, we're going to take the 4 and add 2 of them. That's how the 8 comes from. So the opposite of adding is dividing. And then we're going to square these, so the opposite of that is square root. All right, so let's go back to these. So here is the perfect square form. And again, some of you guys don't really have to do this part here, but it's going to help you, because now what we're going to do is we're going to start with trinomial, and we need to write it in this form. Okay. And so again, if you just take your b, divide it by 2, square it, that gets you your c. And find the last one. All right, I think there was a couple more for you to try. No, never mind. All right, so we are finally ready to learn the method called completing the square. This method has many uses, but one of the ones we will use today is to manipulate equations from standard form to vertex form. That's what we're trying to get to. All right, let's try that again. Sorry, there we go. All right, so we have this quadratic right here. This is in trinomial form, and it's graphed over here. Considering only the binomial x squared minus 4x, what would you need to add to it to create the perfect square trinomial? So basically, we want to know what third term would we need to make this into one of these nice perfect square trinomials like these here, which could be converted to this. So we have a binomial. We want to know what can we put down here to make it into a perfect square binomial like this. So remember, the process is if you just divide this middle term by 2 and then square it, that gets you what you need. So that's kind of what we do here. So remember, take your b term, divide it by 2, square it, and that's what we would need to make it to a perfect square trinomial. So if I wrote it something like x squared minus 4x plus 4, you could see we could factor that into x minus 2 squared. That would get that one there. So if we were able to add 4 to this binomial, it would turn into a perfect square trinomial. So in order to add 0 to this binomial, what would we need to subtract to offset the adding 4? So if we're going to add 4 to this, well, you can't just take a number and randomly add 4 to it if you want to. So to offset that, we're going to subtract, obviously. If we just subtract 4, then technically if we added 4 and subtract 4, we really didn't do anything to the number. So that will allow us to do something with that. So we need to subtract 4 to offset the adding 4. So these would cancel out. And you say, well, why would I bother adding 4 and subtracting 4? That doesn't make sense. You'll see when we start doing some of this stuff. All right, so here is where we're going to learn how to complete the square. This is tough, so follow along, hopefully. So use the method of completing square now to rewrite this trinomial into equivalent shifted form. So as you can see, this is not a perfect square trinomial. Okay? If I take the b term, -4, divide it by 2, -2, and then square this, it does not get to that third term. So you won't be able to factor this really quick and easy. So first thing is we are going to figure out what we need to do for this. All right, so let's see if you can follow. Now this trinomial is basically coming from that binomial we have. You can see we just had the -1 from it. So this was the binomial we started with. Now we decided that if we added 4 to it, it would come into a perfect square trinomial. So if we took our original binomial here and added 4 to it, which is right there, then that thing would be a perfect square trinomial, just what I circled. However, again, you're not allowed to take some number and just decide to add 4 to it. So then what we'll do is subtract off the 4, and together this really here makes 0, and now we really have the same trinomial we started with. So hopefully you'll see that this would cancel out, and now you're left with the trinomial that we started with. Now, however, there is a reason to do this. Now we can start signaling things around. What we did is they took this and they just separated it into a trinomial that's here. Then they combined these two and made -5 there. Now you can see this is a perfect square trinomial. It can be factored into x minus 2, x minus 2, which is this here, and then you have the -5. And now you can see that we're left with it in shifted form right there. So that's what this part is here, is the shifted form, and now we can find the vertex pretty easy. So that is completing the square. So we'll keep practicing it. It's not super easy, but you'll get it down. All right, so an algorithm is just a set of rules. It's like a recipe of what you need to do when something happens. Okay, so when you have some quadratic in the normal form, and note that the a is 1, we'll deal with that later, then all you do is take half of the b term, square it, and add and then subtract it. Okay, so I'm going to do one of these with you and you could do the rest. So write the quadratic in vertex form by completing the square, then identify the quadratic turning point. Okay. So let's look at this first one here. So here's the process, what it says. Take your b term and square it. So here's our b term. Divide it by 2 first, and then square it. Now I wouldn't do all this work. This is kind of set up kind of weird. What I would do is just take your 6, divide it by 2, and get 3. And then I'd get 3 squared, and that's what's coming on right there. Okay, so I would just do it separate like I did. I wouldn't write this fancy way out like that. So again, 6 divided by 2 is 3. 3 squared is 9. And then you're going to add the 9 and subtract the 9. And then in between the third term, so see this -2? We're going to put the new stuff in between that right there. So kind of separate these two guys and insert the +9 -9 right in there. Now look, there's the +9 -9. Then you're going to group the trinomial, so make sure that this is a perfect square trinomial now, which it is. And then you're just going to combine like terms with those. So again, this was factored into that, and this was combined into that. And now look, it's in vertex form, and now we can see it shifted, and there, our turning point. So it does say that some of these are going to involve fractions, not a big deal, but still follow the same procedure. So give these a try, and we'll go over the answers, see how you do. So hit pause and try that now. All right, let's take a look at this one. So again, now I take that middle term, divide it by 2, and square it, and that gets to 1. So I really don't need to see this step for you guys. What I would like to see is, again, look, there's your +1, -1, because 2 divided by 2 is -1, and -1 squared is 1. So remember what you're going to do is you're going to insert it in between the second, third term. So there's the +1, -1. So therefore, you're really not adding anything to this. And the reason you're doing that is because now here is a perfect square trinomial. So we could factor this guy right here into this below, and then we just combine like terms of -1 and 11. Now it's in the right form. So I won't explain all of these, but if you have not finished the rest or you need to change them, you should change them as you go, and I'll reveal the answers. So hit pause and continue work if you need to. All right, part C. So again, you can see that -5 divided by 2, -10 divided by 2 is 5, and then the 5 squared is the 25 minus 25. There's my perfect square trinomial. Combine like terms. Okay, and there's vertex form. So hopefully that's going to, and this is called completing the square, this process. All right, so we're running out of time, so I'm going to reveal the answers here. Make sure you get them all. Now these last two are pretty tough because they deal with fractions, but you could still deal with fractions. You're smart guys and ladies, sorry. All right, so there we go. That would be 4. 4 squared is 16. So 16 minus 16. So notice this one didn't have a C term. So you're just going to do the plus and minus right there. And remember the first 3 is what your trinomial is. Factor it into that. Minus 16. There we go. So I'm running out of time. Look what they did. You could still do math. When you square 5 over 2, it just becomes 25 over 4. Okay? And here's the last answer. All right, I know some of you might be confused, so we'll help you in class tomorrow.